So connecting smaller cities, the 3-tier cities, if 2-tier cities probably are all already connected, maybe one level below. So it envisages providing connectivity to sectors which are not so far being connected by air travel. So this is one of the government schemes which is aimed at increasing the air transport as well as the overall revenue in that in aviation industry. And then we have this big question mark. So I have carefully avoided any recent data because we know 2020, 21, 22. There are some data, there are some tables, etc. We probably will use it for the class presentations, or I will request some of you to gather some of them and present the COVID impact. Certainly, COVID has an adverse impact on the aviation segment. I mean, all across the globe. So that's not a. I mean, it's very obvious that everybody was impacted. Aviation segment also was particularly impacted, and in India we know that large number of flights had to be cancelled, both international as well as domestic. And as we know, the issues are still unresolved, and in the recent days it has been growing, etc. So the COVID impact is probably yet to be quantified completely. How it is going to affect the future growth, or how is it going to even affect the existing scenario, or what is going to be the impact on some of the major companies and smaller players, etc. Probably the clear picture is yet to emerge in that. But that has to be factored into when we talk about the presence as well as the future of Indian aviation industry. Okay, so with that, I wind up the discussion on the history of Indian aviation. So we have covered the situation till as it is now. Just touched upon the trends and the factors that reflected in the kind of growth and issues related to aviation industry in India. Uh, I will now move on to the next topic in the syllabus, the SWOT analysis of aviation industry, Indian aviation industry in particular. Before I do that, I'll pause for a while. If you have any questions, please. Again, no questions, comments. We'll move on to the next topic, the SWOT analysis. I'm not sure whether you have come across SWOT analysis earlier. Engineering subjects probably will not have a discussion on SWOT analysis. If you had any management topics or other humanities subjects, it's possible that you are already familiar with what is known as SWOT analysis. Even otherwise, from your general reading, you probably would have come across what is meant by SWOT analysis. Anyway, we'll just, even if you are familiar with that, we'll just review the terms and we'll see what it means for Indian aviation industry, because that is specific to the syllabus, the SWOT analysis as applied to Indian aviation industry. SWOT analysis is a management tool actually in management quite often this terminology, in applied management, SWOT analysis is quite often used. In industry, people are often at managerial levels. People are often asked to make SWOT analysis of their respective groups or the activities of their groups, their teams, etc., and then make recommendations on how to improve, how to grow, etc. So it's quite commonly used analysis tool in management. SWOT is an acronym for strengths, weaknesses, opportunities, and threats. So SWOT, SWOT. It's an organizational used at organizational level to examine how closely a business is aligned with its growth objectives and trajectories. So, as we know, any business initiative, any venture will have certain objectives laid out, should have certain goals and objectives laid out. Now, at a given point of time, how well the organization is aligned towards its towards the achievement of its objectives. How well the organization is making the resources that are available to it to achieve those goals, or what are the drawbacks, what are the perceived issues that can sort of impede the growth. A combined analysis of all this is referred to as the strengths, weakness, opportunities, threats analysis, known in short as SWOT analysis. So it's a part of strategic management. Strategic management is, as opposed to management as it comes, it's like making things happen, or make learned decisions based on the information about the available resources and the information about the issues ahead. So how to strategically plan the resources, how to strategically plan the growth as well as the activities. That's the core theme of strategic management, and it forms the basis of it. It should form the basis of decision making processes, and the what it achieves to gain is to have higher organizational performance. So basically, the management should be able to, from the based on strategic decisions, the management should be able to examine the situation and adapt its business to the changes in environment, and it should coordinate across different units, different teams, different groups, etc., to help them align, to get themselves aligned along the organizational goals. So the approach, the comprehensive approach that makes this happen is referred to as strategic management, and SWOT analysis is considered to be an integral part of strategic management. The role of SWOT analysis, that is, where does it fit? The analysis that we are talking about, the SWOT analysis, where does it fit in the overall scheme of things, or the overall scheme of activities? First thing, as I mentioned, when you have an organization, it's understood that there are a set of identified there is a set of identified mission, a set of goals which are laid out, and strategies which are laid out to which can help achieve those goals. So mission, goals, and strategies, these are expected to be there with the organization. Now, once you have this set, you need to, the organization should know what are the factors that it has at its disposal which can help it gain these. What are the shortcomings that it has which it should address when it tries to when it strives to achieve these goals, and what are some of the external factors which probably will retard its progress, and what are some of the external factors which it can make use of favorably to achieve these goals. So this entire analysis is what is referred to as SWOT analysis. So SWOT analysis comes when an organization with a set of is functioning with a set of mission goals and objectives and with a given infrastructure and active resources at its disposal. So strength, weakness, opportunities, and threat. These can be usually classified as external factors and internal factors. Strengths and weaknesses are considered to be internal to the organization. Strengths are the internal strengths of the organization. Weaknesses are weaknesses which are inherent to the organization. As opposed to this, opportunities and threats, they stem from factors which are external to the organization, on which the organization probably doesn't have a control on. Say, for example, if you have a agricultural firm or you have a business that is closely related to agricultural, the climate patterns or weather changes and the impact of that on the agriculture, etc., is certainly going to be a concern to you. But a climate change, as far as this company is concerned, is something which is external to it. It doesn't have a control over that. So such factors which are external to the organization are referred to can be classified either as opportunities or threats, depending on how they are going to likely to impact the organization's goals. So strengths and opportunities, strengths and weaknesses are internal to the firm, to the organization. Opportunities and threats can be considered as external factors. SWOT analysis involves a complete analysis, keeping all these together. When SWOT analysis is carried out, then you can formulate strategies based on the findings from the analysis. That is, identification of your strengths, weaknesses, opportunities, and threats. You can formulate strategies that is which will make use of your strengths, which addresses your thought, which addresses your weaknesses, which capitalizes on the opportunities ahead, and which mitigates the threats which are external to you. So the strategies should be resembling or reflecting your understanding about the complete SWOT picture. And then strategies can be formed, implemented, and then from time to time, the results of the evaluation has to be evaluated. And it's a cyclic process. You may have to repeat it. So this is where the SWOT analysis fits into the scheme of strategic management. We'll try to go into some more detail of all this and then try to see how that applies to Indian aviation industry. But for now, I'll just stop here. If you have any questions, you can please ask. Otherwise, I'll request team 1 to start their presentation. Share the slides and have the presentation. Before that, any questions? Okay, if no questions, comments, we'll go to the presentations. I'll stop sharing the screen. If one can please start. Stop here. Team 1, Adarsh, Akshay Nivasani, Ashwin Sridhar, Giridhar, Sri Supernai, Kevin, Kevin, and Krishna Murali. I would, I guess, Aishwarya, are you available? I guess she was auditing, but then I think she is crediting. You are now crediting, right? So
Yes,
you can join the first team. So I'll update the list in such a way that You said your roll number is 18, right?
Yes, sir, it's 18.
So you can probably join the team one. I'll update the list accordingly.
Thank you.
Yeah. So whoever is presenting can please share the team and share the screen and start.
Sir, good morning, sir. Can you hear me, sir?
Can
One
you see the
second.
screen, sir?
I can see. I can see. Yeah. Thank
Yes, sir.
is that in slideshow mode already?
Yes, sir.
Yeah. Okay. Great.
So,
Thank you.
good morning, all. I'm Adarsh Shah, here to present on the topic Bell X1 on behalf of my team. So, next slide, Kevin. So, this slide gives an overview about the presentation. So, I will be next slide. So, I will be starting off with the historical importance of this aircraft. So, the concept of experimental aircraft was seriously taken into consideration during the World War II by the US and its allies and its counterpart USSR. As a result of this mounting tension between these two nations, the idea of supersonic aircraft came into existence as a result to overcome the sound barrier. So I'll be the Bell X1, originally designated as the XS1, where X stands for experimental and S stands for supersonic aircraft. So it was a joint research and development by the NACA and United States Air Force. And after this collaboration between NACA and USF, this immense piece of intense piece of research was put into an aircraft was done by the Bell Aircraft Corporation. And after that, numerous unpowered high altitude glide tests were conducted to assess the aerodynamics and stability of this machine. See, on the other hand, the United Kingdom was developing its own supersonic flight program. And later, after some time, a memorandum was signed between two nations in exchange of this technology. And UK was developing the Miles aircraft. And this aircraft was first manned, supersonic flight, that is supersonic level flight, was first manned by Chuck Yeager. He was a pilot. And it broke the sound barrier on the year 1947, on October 14th, 1947. So that is just 2 years after our independence. So next slide. So this just a quote of Chuck Yeager, which inspired me. So I just wanted to share it with the class. So rules are made for people who aren't willing to make up their own. So next slide. So this is the design. So the design, right side image shows a blueprint of the X-1 aircraft. And this design actually was inspired by a .50 caliber bullet, which was used in machine guns, was capable of moving at supersonic speeds. And also the other notable features like variable tail incidence and liquid rocket engines. So this liquid rocket engine is a four-chambered liquid rocket engine, which was developed by reaction motors, and also it had an all-moving tail and a stabilator, also known as a stabilator. And the key important fact is that it was not capable of being ground launched. Maybe the later variants were capable, but the Bell X1 was air launched from the B-29 Fortress. And the next slide. Okay. So the variants, so these are the variants. So starting from X1A to X1E. So these five variants are result of the immense work of engineers under extreme pressure and constraints given by the government. So starting from the aerodynamic phenomena of speeds greater than Mach 2 and aerodynamic heating instrumentation for thermal research, up modifying the propulsion systems by incorporating a turbopump fuel feed system and test for testing armaments and ammunitions in high transonic and supersonic flight. So next, just a second, Kevin. Yeah, can you just pause the video, Kevin? Kevin? Yeah. Yeah, can you just share the audio if possible? So this is a small clipping.
There she goes. A big moment in a history-making flight. Now she's approaching the barrier. The speed of sound at 35,000 feet is 660 miles per hour. The relay big moment. Through the sound barrier. The first time ever in level flight. For the first time, except in...
So this is just a small clipping where the Bell X-1 aircraft broke the sound barrier. And we're just saying about the timeline of this aircraft. And the final flight of this X-1 rocket plane program came to an end in the year 1958, just after 12 years of its existence. And we're just saying, starting with Jack Williams, he was the first chief pilot of the Bell Aircraft Corporation. So who completed a series of glide tests dropping from B-29. And also did some powered flight tests capable of reaching Mach 0.798. And later, after his demise, Chalmers Slick Goodwin was the next pilot. So he also performed numerous glide tests and also powered flights, reaching up to speed of Mach 0.9. And there were some certain issues about handling qualities and stability at such speed. And later, the United States Air Force was not happy with the progress and hence terminated the contract with the Bell Aircraft Corporation. And then later came our Chuck Yeager, the USF pilot, and he named this his first flight as Glamorous Genesis in fond memory of his wife. And he broke the sound barrier, and that is a video which we just saw a few seconds ago. So next slide, Kevin. So this is just a brief technical specifications of this aircraft, as I just don't want to specify almost all technical specifications. It's like the length is around 9.42 meters, the wingspan, and the height and wing area. And the power plant, as I said, it was manufactured by the reaction motors, capable of producing 27 kilonewtons of thrust. And the max speed, this specifications is for the Bell X-1 aircraft, not for the other variants. And the maximum speed it reached was almost around 1,100 kilometers per hour at some 35,000 feet altitude. And the Mach number was around 1.06. So next slide, Kevin. And the legacy, it's about the project established the clear pattern for all subsequent experimental aircraft projects. So it just gave an insight to the engineers on how supersonic travel is possible. And the flight data was collected by the NACA team, and it helped in further designing the supersonic aircraft still later half of the 20th century. And maybe in terms of propulsion point of view, like it was not being very useful as nowadays it's not. You don't use rocket engines for aircrafts, as we have come up with ramjets and scramjets. And in memory of this aircraft Bell X-1, the United States Postal Service actually released a stamp commemorating the Bell X-1, the first plane to fly faster than the speed of sound. So, and then I would conclude by saying that this aircraft has made a history and will be a part of history in terms of supersonic travel, speed of sound and beyond. Yeah. Thank you. Sir, I'm done with
thank you. Thank you. Good informative presentation. I just have a couple of minor. Others also, if you have any questions, you can ask. Just couple of small questions. You said the Mach number was 1.06, right? That's the maximum that they achieved in the flight, is it?
Yes, sir. Actually, Bell X-1 achieved a maximum of 1.06, sir. But other variants like X-1A, X-1B, they achieved much higher speeds, sir.
Fine. And in this Bell X also, that X is X stands for experimental, is it?
Yes, sir.
You said X in Nexus, you said it X is.
Yeah. Here for Bell X-1, it stands for experimental, but later the supersonic term was removed, sir. It was just Bell X-1.
Okay. And also those variants that you listed, all of them made use of a rocket engine, is it?
Yes, sir. Yes.
That I guess you had that XA, XB, I don't remember the namings.
Yeah.
So maybe they all of them were making use of rocket engine, is it?
Yes, sir. Yes, sir. Rocket engine, sir. But with certain, maybe with some sort of modification, sir. Because I was not
Yeah.
about like I don't want to make it too technical, so I just gave a brief.
That's okay. That is fine. Yeah. Okay. Okay. Thank you.
Fine, sir.
For this question, they can.
Yeah.
If there are no questions, you please upload. As I mentioned, you just upload the presentation to the the team folder. Okay.
Okay, sir.
We have already uploaded, sir.
It's uploaded. Okay. Thank you.
Fine, sir. Thank you, sir.
Okay. Thank you. Thanks, team one. So we'll go to the next team. Team two, if you can also do the presentation, it'll be good. Lakshmi, Shivakumar, Naresh, Nitin, Niveta, Pavan, Ramnathan, Ranesh. Yeah, the slide is visible. You can.
Hello, sir. Am I audible, sir?
Yeah.
Yes, sir.
Some disturbance. Yeah.
So good morning. I'm Naresh and I'll be presenting on Tupolev TV-144, and these are my group members. So starting with the year of operation, the Tupolev TV-144 is a Soviet supersonic passenger airliner, so which was in operation from 1968 to 1999. So after 1999, they stopped the production because it was considered to be a failure model. So the Tu-144 was the world's commercial transporter to exceed Mach 2. And it went supersonic first on 1969 on 5th June. So this is about Tu-144. So moving on to the historical importance. So as I told before, the Tu-144 experienced many failures. So its major first failure was experienced on 1978. So during a test flight, there was a crash landing and two crew members in that flight actually died. So yeah, and its last flight was in 1st June of 1978. So in upcoming years, there was a variant which came through, which is Tu-144D, which was built in 1981, and it was primarily used for medical and biological research purposes and other steps, and it ran till 1988. So after that, it was stopped due to again lack of funding. So and in further in 90s, the NASA stepped in and to even modify the Tu-144D, they funded few things so that they could create a new variant which was Tu-144L. And this was considered to be a technical success, but in the year 1999, due to lack of funding, it was again cancelled. So this is about the historical importance, and moving on to the earlier design. So you can just see the early design of the aircraft, which is a twin-engine aircraft, and because you can see the supersonic aircraft it has a slender body. Yeah. The design dimensions and the specifications, not going to tell everything. You can just go through it. So the overall length was somewhere around 65.7 meters. You can just go through it. So moving on to the performance, the important thing is here the cruise Mach number. The cruise Mach number is 2. So like you told before, this is the first supersonic passenger aircraft to have a cruise Mach number of 2. So other things you can just go through it. Yeah. Okay, the next slide is about the reason for failure and cancellation. So I'll pass it over to Lakshmi to talk about it. Thank you.
Good morning, sir. Now I am going to tell about the reasons of failure and cancellation of Tu-144. From the reports, it has been found that from the early stages, the Tu-144 is extremely unreliable as it has gone through 220 plus failures in the taken 1 or 2 flights. And majorly when even after the inauguration in the next 2 weeks the flights Tu-144 flights has been cancelled, and it has been misreported to the journalist as a bad weather, but they have been uh, cancelled the journey because of the overheat in the exhaust valves. And from the further flights they have made the chief design engineers to be present before the flight to check the flight before every takeoff. So this shows how extremely unreliable the Tu-144 is from the earlier stage itself. And the limited routes, the only one commercial route is Moscow to Alamata, and it flies only once for a week, and it can carry only 60 to 80 passengers. So there is a more demand for the seats, and the availability is very less, and the flight is not that much reliable as it can make more number of rounds. So the officials couldn't take a further step to provide more number of flights. And another thing is airframe test failures. And before the introduction introducing the Tu-144 to the passenger service, they have found serious problems in structural failures in the laboratory testings. And the one more thing they have found is there is no resisting. It doesn't have a property to resist the crack growth, and and also they have found the fatigue cracks which are above the acceptable limits. But these all the informations are not exposed outside, but they have kept for themselves until 1978. And the cabin noise is a very problematic thing as it goes above 90 to 95 decibels on average. This is because of the unique heat insulation system designed for this for air conditioning in this aircraft. Next slide. And these all the reports have brought out because of the British, as the Soviet Union has seeking help from the European countries for developing and making changes in the design of different things. The list goes like de-icing equipments for the leading edge of the air intakes, fuel system pipes, controls, and many things. And the British government said didn't didn't accept their approach, and they found threat like they may use this in the Soviet bombers. And the British also published these reports in the mainstream press of the time, in that as such as the Times. Next slide. Now, one more major factor is economic inefficiency. At the 1970s, the fuel prices rose, and they made a decision to stop the Tu-145 and introduce another jumbo jet, which is Ilyushin Tu-86, which became a flagship airliner for Soviet. And the next decision to seize the Tu-144D production was issued on 7th January 1982. Is followed by complete seizing of Tu-144 program was brought up on July 1st, 1983. And the other which are already produced Tu-144 aircrafts are given to flying laboratories. Next slide. And we have in the further you have seen in the past, these are the variants which are produced in the development of Tu-144. Tu-144 is the sole prototype, and the further Tu-144S and D are the modified with different engines or afterburners. Next slide. Thank you.
Thank you. Good presentation, actually. Just a couple of points. One is you mentioned the cabin noise as one of the technical issues, practical issues actually related to the operation. And I guess you mentioned the dB level as 90 and above, right?
Yes, sir.
I would expect that was at average level. So what is currently, say, for modern aircraft, what is cabin noise level typically?
Sir, I don't know, sir.
No, just find it out.
Yes, sir.
When you have next presentation, team 2, please make sure that this additional information you present. Okay. I mean,
Okay,
the
sir.
topic will be different, but this additional information, you just put that. You get the data, just put that. That will be informative. Okay. That
Okay,
is
sir.
a typical cabin noise for commercial aircraft. Okay. And if you have for military aircraft, that's well and good. But more important is commercial aircraft. Okay.
Okay, sir.
And I guess you have listed what all led to the downfall, which was actually a very short lifespan for an aircraft. I guess the commercial usage was only 5-6 years before it was. Then I guess then it was made use of for whatever other cargo or biological or something what you mentioned here. So it's very short. But then there's one more question that I had. Oh, okay, not a question. Actually, can you go to that one of those slides where, say, for example, you mentioned, you go before this? I forgot that. Okay, yeah, just come down one by one. I'll ask you to stop when I reach that. Next one. Yes. Say this is the feedback actually for everybody. When you present, don't have such long text. Okay. Uh, running text to be
Sir,
so
to include the
long.
list
It's better to put them as shorter
points.
bullet points. Okay.
Yes, sir.
So they need not be usually for presentations. It need not be full sentences. You can have sentences, but it need not be full sentences. You can just list them as bulleted points, which will be easier for the listeners or for those who attend the presentation to read as well as understand. If you have more things to convey, then you can use your explanation, but you don't have to put everything on the slide. Okay, so just keep that in mind when you. I mean, it's not just for this course. I'm just giving it as a general feedback whenever you work on any presentations. Okay.
Okay, sir.
Good presentation. Thank you. Thanks. Others have questions they can ask. Others will stop for that. We will stop the session. Okay then. See you all in the afternoon. Thank you. Thanks to all of you for the invite.
Thank you, sir.
Thank you. Thank you.
Thank you. Thanks.